In this video, we're going to have a look at place value and where it sits within the GCSE Foundation Mathematics course. Also going to look at converting some simple units, doing some estimation, rounding to significant figures, and using some information about calculations to work out other ones without a calculator. So let's get started. So these first two, it is to write numbers in figures, and what that means is to use digits or numbers to display the number that is written. So we've got 5.2 million. 5.2 million is going to be a number that starts with a 5, that starts for the 5 million, and then it is followed by a 2, that's the 0.2. And you need to make sure that there are 6 digits written after the 5. So we have 5 and then 2, and then we've got 1, 2, 3, 4, 5, which makes 6 digits in total after the 5. Do the same with 10.86 million. Once again, you start off with the 10, that stands for the 10 million, and then that needs to be followed by 6 digits. 2 of those digits are 8 and 6. And then we fill in the rest with zeros. Now we can go the other way. So this number we've been asked to write in millions. So if we think, right, I've got 1, 2, 3, 4, 5, 6 digits after the 3. Therefore it is 3 million. And after the decimal point we will have a 2 and a 1. And then we simply just write the word million. Similar with this number, we go, right, okay, I've got a 24, and then that is followed by 6 digits. So it is the 24 that comes before the decimal point, and then we have a 6, 5, and a 7 after the decimal point, and write the word million. In the next question, we're looking at converting some units, and I've included a box here of some of the rules that we would follow in order to convert from bigger units to smaller units and vice versa. As you can see, we can start at what are known as gigameters, and to convert them to smaller units you keep multiplying by 1,000. Likewise, if we started with a small unit here of nanometers, we can convert those into bigger units by dividing by 1,000 each step. Now, naturally, there are other units in between. For example, we'd have centimetres there. But you get the idea. So in order to convert 3,215 metres to kilometres, I've got metres and I'm converting to kilometres, which means I am going to divide by 1,000. Now, there are various ways. You've just got to think of how the place value works. I would have a decimal point that would be between the 3 and the 2, because currently my decimal point is here, and if we imagine either the decimal point moving to the left or the numbers shifting to the right, doesn't matter which way you do it, you will get 3.215 kilometres. Okay, next one, 310,000 millimetres to metres. Well, to get from millimetres to metres, we divide by 1,000. And similarly, we look to see what happens there. If I divide this by 1,000, I'm going to be left with 310 metres. Final one is to convert from metres to millimetres. I have 0.0004, and we want to convert that to millimetres. So I'm at metres, and I want to go to millimetres, which means this time I am multiplying by 1,000. So either shift your numbers to the left or decimal place to the right. We're going to be left with 0.4 millimetres. Our next example involves rounding to significant figures. A significant figure is the first one that is a non-zero. And we'll come on to an example with that later on. For this one, to round this to three significant figures, I count from the first significant figure, which is 8, to the second, which is 4, third, which is 6, and it is actually the 7, the fourth significant figure, that will determine how we are going to round this number. 7 is 5 or more, therefore that rounds the 6 up to a 7. For our next number, we have 32,759, rounding to two significant figures. So again, we look to see, and we actually look at the third significant figure, which is a 7, and see what that will do to this second one, which is a 2. 7 is 5 or more, so therefore it is going to round that 2 up to a 3. But you can't leave your answer as 33. 32,759 will not round to 33. You have to fill in zeros as place fillers to keep the same place value and same overall value of your number. So it becomes 33,000. Estimation is an important skill to have so that you can work out to see whether an answer is roughly correct before moving on. Rounding to one significant figure, or a sensible degree of accuracy, is the best way in order to estimate. So what we're going to do for this question is we're going to estimate each answer. We're not going to look for the exact answer, we're going to estimate it by rounding each number to one significant figure. 312 will round to 300. 876, well the 7 is 5 or more, so that rounds up to 900. So our estimation becomes 300 times 900, which is 270,000. Notice that we had an approximately equal to sign, or a squiggly equals. That means that it is not exactly equal, it is approximately equal. For our next one, we have 22 times 687, all divided by 2,109. Again, because this is an estimation, we don't initially use the equal sign, we use the approximately equal to sign. And we round each number individually to one significant figure. 22 will round to 20. And that is multiplied by, in this case, 700, because the 8 rounds the 6 to a 7. That is all divided by 2,000. Because 1 is less than 5, so the 2 remains the same. Now, rather than trying to do the full multiplication, we can actually do some cancelling out. If you can see, because we have a multiplication here, we can cancel out some zeros there. We can cancel out another pair of zeros, another pair of zeros there, and then finally, we can cancel out the 2's. So our estimation, the calculation here, becomes quite straightforward. We have 1 times 7, which is 7, and that is divided by 1. So our estimate is actually 7. Our final one involves decimals. Rounding to significant figures does not make any difference, even if it's a decimal. So we start with our approximately equal to sign. 5.74, well 7 rounds the 5 to a 6. Times, and the 1 does not round the 5 up, so it becomes a 5, and that is all divided by 3. And then we can do this one in our head. 6 times 5 is 30, divided by 3, that will give me 10. In our next question, we have an exam-style question. We've got a reminder here of how we deal with fractions that involve calculations. You simply do calculation 1 and divide it by the calculation 2 using priority or order of operations. So our first part of the question is estimate the value of 98.54, add 4.83, all divided by 6.71 minus 5.09. There's quite a lot going on there, so we're going to do the estimation first. We round each number, in this case, to one significant figure. 98.54, well, the 8 will round the 9 actually up to a 10, so it becomes 100. And that is then plus, around this number, that becomes 5. And that's all divided by, again, we look at the 7, that's going to round the 6 to a 7. And that is take away the 0, it's going to round that to a 5. So we now have 100 plus 5 divided by 7 minus 5. That is 105 divided by 2. So if we halve 105, we will get an answer of 52.5. Our next part actually tells us to go on and calculate the value using a calculator to 3 significant figures. So let's type that into our calculator. So we can start off, we can actually press the fraction button straight away. And we enter in our digits into the numerator. So I have 98.54. That is add 4.83. Press my down arrow to get to the denominator. And I have 6.71. And that is subtract 5.09. Check that's all okay. Now we've got a fraction as our answer there. On this calculator, to change that to a decimal, I press Format, the down arrow, and OK for decimal. And I get an answer of 63.80864,198. Okay, so it's good practice to write that answer down in full. Okay, you should always write your full answer down and then round it. So in this case, we've been asked to round to 3 significant figures. So we look at the 4th significant figure, which is the 0. That, of course, is less than 5. So it keeps our answer as 63.8 to 3 significant figures. In this final example, we have to use information that are given about a certain calculation in order to make other calculations. And this will not use a calculator. It would be on the non-calculator paper. So the information we've been given is we've been told 265 multiplied by 34 equals 9010. And we're to use that fact to work out the value of 265 times 35. Well, if you see that actually 35 is one more than 34. So we're actually doing one more times 265. So to work this one out, we can start with the answer we were given in the question, which was 9010. And we can simply add one more lot of 265, which will give us 9275. Part B is a little trickier because it doesn't appear to be written in the same way, but we do have some similar looking figures in the question. So what I'm going to do is I'm going to just rearrange the way this original question is written so that it looks like a division. Okay, if I apply the inverse calculation, I can do 9010 divided by 265. That gives me 34. So now let's have a look and see what is the same and what is different about the question we have here and the calculation that we've taken from the question. Well, 90.1 is 9010 divided by 100. So we have divided our original number by 100. However, we're then dividing by 26.5. that is actually 10 times less than 265. So the calculation we're going to do to 34 is first we're going to divide it by 100 because 90.1 is 100 times smaller, but then we're actually going to multiply it by 10. So that means 90.1 divided by 26.5 will equal 34 divided by 100, which is 0.34. However, before I start writing 0.34, I have to then appreciate that I'm actually dividing by a number 10 times less. So I multiply that answer by 10. So it becomes 3.5.